The latest AI obsession is loop engineering. It's all over X and LinkedIn right now, and Andrew Wang just put it at the center of the conversation with its latest batch newsletter. And I know, when a term spreads that fast, it starts to smell like a buzzword. But this one isn't, I promise you. Loop engineering is the actual technical description of how production AI systems are being built in 2026. And once that clicks, most of the confusion around AI agents will just disappear. So in this video, I'm going to break down what loop engineering actually is, why has the field moved from prompt engineering to context engineering and now to loop engineering, and how do you design agentic AI systems that hold up in production instead of falling apart the first time something goes wrong. Specifically, we'll cover harness engineering and why the boring deterministic code wrapped around your model really decides whether that thing is going to ship. Then we'll also talk about how do you manage context and verification inside a long-running loop. And then finally, I'll talk to you about Mint framework, which my co-founder and I teach for building these systems without drowning in complexity. I'll also show you how Andrew Ng's 3 nested loops and his 4 original agentic design patterns fit into all of this. And I promise you, I'll anchor everything with a running example so none of this feels abstract to you. See, first thing what you need to understand is loop engineering isn't theory. Loop engineering actually came straight out of the teams which were building coding agents like Claude Code. And it is the same pattern behind AI native companies that used to handle work that used to take entire floors of human agents. Now, if you're new to my channel, I'm super glad that you're here. I'm Aishwarya Srinivasan and I have 10 plus years of working in machine learning and AI. I have a master's degree in data science from Columbia University and I've worked at companies like Google, IBM, Microsoft and Fireworks AI. And currently I'm building my own AI startup. So anything that I'm sharing here is actually coming from my own experience building agentic systems. So while we're getting started, let's start with the shift because this actually explains everything. So a couple of years ago, the highest leverage skill in AI was prompt engineering. You crafted the exact wording of the prompt because every phrasing genuinely changed the quality of the output. The model was very rigid, so the input words carried all the weight. Then the models got better and the bottleneck actually moved. It stopped being about phrasing and started being about what the model could see at inference time. Now that was context engineering. Instead of tuning words, you're actually curating everything that lands in the context window of the model. So things like retrieved documents, the conversation history, the memory, and tool results, etc. The model can reason over almost anything right now. So your job is actually assembling the right inputs. We are now in the third era and this one is called loop engineering. So this is the actual shift that's happening. The model can write its own prompts and it can pull its own context through tool calls. So the input is not a scarce skill anymore. The scarce skill is designing the loop the agent runs inside. What does it do between the steps? When does it check on its own work? When does it decide when it's done? And what happens when a step fails? So loop engineering is actually designing that cycle, which is act, observe, verify, retry, instead of handwriting every step yourself. So this is one example that we're going to talk about for the entire video. Let's say that you're building an AI customer support agent for an online store. It would answer order questions, handle refunds, and check shipping status. Everyone has dealt with one of this, so it's easy to picture and every concept in this video would sort of attach to that. Now, there is a layer underneath all of this that people completely forget and it's called harness engineering. We'll get there because that's where most agent projects secretly fall apart. But first, let's be precise about what the loop even is because most people wave at it without even defining it. So here is the primitive underneath every agent. The model gets called, it decides on an action, which almost always is a tool call. Then the harness executes that action. The results come back as an observation. That observation gets appended to the context and the model gets called again. If you've heard of the React pattern, that's exactly this. Reason, act, observe, and repeat. Okay, let's walk it through the support agent example. A message comes in, then iteration 1 is where the model classifies the intent as request refund. Then iteration 2, it decides that it needs the order details and calls the order lookup tool. The observation, the order record comes back into context. Then in iteration 3, it checks the refund against the policy. Then iteration 4, it drafts the reply and either sends it or escalates it. So each of this is a pass through the same loop. Now here's the piece almost nobody engineers, and it's the single most common failure I see, which is the stopping condition. When does the loop end? If you don't decide this deliberately, you get runaway loops. The agent keeps calling the tool, keeps re-reasoning, keeps spinning on the task that it actually can't complete, and it burns out the token the entire time. So you need explicit termination. Things like a model emits a clear done signal or a final answer, or a hard cap on iterations, or a cost or token budget that kills the loop, or a verifier that passes and ends it. In production, you usually want several of these at once because the model's own sense of when I'm finished is not something that you can fully trust. And understand the economics here, because this is what makes loop design a real engineering discipline and not just a diagram. Every single iteration is actually a full model call. That means latency and cost scale directly with the loop length. An agent that takes 10 steps to do a 2-step task is not just slow, it's 10 times the inference bill and 10 times the surface area for something to go wrong. So a huge part of loop engineering is actually minimizing unnecessary iterations. Give the model the right tool so it doesn't fail. Give it enough context upfront that it doesn't waste 3 loops rediscovering what it needed. The tightest loop that still completes the task reliably is the one that you want. Now, I want to get into the mistakes that I constantly see. People treat their agents like a single point solution. With a coding agent, they obsess over the code generation in isolation. Now, with our support agent example, engineering team might be pouring weeks into making the reply writing sound perfect or into making the intent classifier razor accurate, and they tune that one component to death. This is not how the systems work. The support agent is not a reply generator. It is a loop, and every step feeds the next one. If your intent classifier is flawless, but your order lookup tool times out and there's no handling for that failure, your flawless classifier is useless because the loop stalls right after it. So optimizing one node in a graph where every other node depends on the others get you almost nothing. Before we get into the next section, I want to take a quick minute to talk about one of my biggest productivity hacks lately. It's Granola. One place where it has genuinely changed my workflow is in back-to-back work calls, especially when I'm switching between a team sync, a creator strategy call, or a quick Zoom discussion with somebody else on my team. Normally, the hard part is not just taking notes, it is remembering what actually mattered after the call. What was decided, what did we need to send out, who owns what, and what has to move next. Now that is where Granola fits really well. It runs locally on my laptop and transcribes my computer audio directly. So it works across Google Meet, Zoom, Teams, Slack, and even calls that do not even have a meeting bot joining in. So let's say that I've finished a content planning call for my YouTube video on loop engineering. I can open Granola and ask, what are the final action items? What did we decide for the next video? Or can you turn this into a follow-up email? And because Granola is an AI notepad, it does not just give me raw transcript. I can write messy notes during the call, and Granola turns that into a clean summary with decisions, follow-ups, and next steps. From there, I can send specific notes to myself, share the summary with my team, push an update into Slack, or draft the follow-up email without manually piecing the meeting back together. So if your work involves technical reviews, hiring conversations, creator planning, client calls, or team syncs, Granola helps turn meetings into actual output. You can try Granola using the link in the description, and new users get 100% off their first month. Now, loop engineering asks you to design the whole loop, where everything feeds off everything else, instead of polishing one component and hoping the rest of it sort itself out. Which brings me to harness engineering, and I really want you to internalize this one. When people build agentic systems, they over-index on the non-determinism. They get mesmerized by the fact that the model is creative and unpredictable, and they forget that a production agent is mostly still traditional software. The harness is all the deterministic code wrapped around the model. It is the retry logic when a tool call fails. It is the timeout when the database is slow. It is the fallback when the model returns a malformed output. It is the guardrail that stops the agent from ever promising a refund that it is not authorized to promise. And it is the structured logging and tracing so you can actually reconstruct what happened when something breaks in production. If I'm being very honest with you, the model might just be 5% of the magic. The hardness is most of whether this thing survives contact with real traffic or not. The teams shipping reliable agents right now take that scaffolding just as seriously as the prompt. And this changes how you evaluate completely. Most people evaluate the model's output. Was this one reply good? Now that's necessary, but it's nowhere near sufficient. You have to evaluate the whole system's behavior. You have to think about, does this system reliably resolve tickets across thousands of conversations? When the order lookup fails, does it degrade gracefully or does it hallucinate an order number? How does it handle an angry customer, the out of the policy refund, or a malformed input? You are not grading a sentence, you are grading a system under stress, including its error handling capabilities. This is where you need to set up tracing and evals on real traces with tools like Langsmith or Langfuse. So you're scoring end-to-end runs and not just isolated completions. Now moving from is the output good to is the system actually reliable is one of the biggest jumps that you can make. Now here is a problem that only shows up once your loop runs for real and it catches people off guard every time. As the loop iterates, context accumulates. Every tool result, every intermediate reasoning step, every observation gets appended to the window. On a long task, you don't just risk hitting the hard context limit, you actually hit a quality wall well before that. The model gets measurably worse as the window keeps filling up with stale and low signal tokens. And people call this context rot, and it is one of the main reasons long-running agents start strong and then degrade halfway through the task. So a real part of loop engineering is deciding on every iteration what stays in context and what gets dropped or compressed. A few techniques that people are actually using is one, compaction, which is periodically summarize the earlier steps into short running summaries so that the model keeps the thread without carrying every raw token. The second one is external memory, which means write facts out to a store and retrieve only what's relevant for the current step instead of dragging the entire history inline. And the third one is tool result management, which people forget entirely. Your order lookup might return a huge record or a query might come back with thousands of rows. You do not dump all of that back into the model. You filter, you extract, and you summarize the results before it re-enters the context. This is also, by the way, the real technical reason why multi-agent AI systems exist. You spin off a sub-agent with clean, scoped context to handle one bounded task and it returns just the result to the main loop. That keeps your primary loop's context lean and focused. So multi-agent AI orchestration is often a context management strategy, not just a capability flex. If you take one thing from this section, let it be this, that context is a resource that you need to actively budget into the loop, the same way you budget iterations and cost. Now let's talk about verification because it's the hinge that the whole loop turns on and it connects directly to what Andrew Ang is pointing at. So here is the core idea. Some outputs are cheap and reliable to verify and some are not. And that asymmetry decides how you design the loop. Let's take code for example. Either it compiles and passes its test or it doesn't. That's a cheap, automated, trustworthy verifier, which is exactly why coding agents got so good so fast. The loop can check its own work and self-correct before a human ever looks at it. Now compare that to judging whether a refund decision was reasonable or not. There's no cheap automated way to check for that. So the rule is simple. Whenever you have a cheap, reliable verifier, put it inside the loop so that the agent can catch its own mistake and retry automatically. So for the support agent that we were talking about, checking a drafted reply against a hard deterministic policy rule, say any refund above $100 must escalate, is exactly the kind of verifier that you bake into the loop. The agent drafts, the verifier checks against the policy, and only a passing draft gets sent. Whenever you don't have a cheap verifier, where the judgment is genuinely subjective or novel, that's precisely where a human belongs. So verification is what tells you where automation ends and where human review starts. So it is not a vibe eval, it is a design decision that you need to make per step. So this is my favorite part. How do you design a system with all of these moving parts? The loop, the harness, the context strategy, the verifiers, without it collapsing into an unmaintainable mess. This is what Mint is for, and it's the framework that my co-founder and I teach inside of our Mastering Agentic AI certification. Mint basically stands for Minimal Intelligence Necessary Tools. The philosophy is simple to say and genuinely hard to follow. You build the minimal viable system end to end before you add a single layer of complexity to it. Here's what the sequence would look like for a support agent. Start with a basic prompt and a basic workflow. A message comes in, the agent answers. Get that working end to end, nothing else. Then add a tool use so it can look up an actual order instead of making one up. Then add continuous evaluation so you can actually measure whether it's really resolving tickets or just failing quietly. Then you add state and memory so it remembers the customer across the conversation and across past tickets. Then add more workflows, a dedicated refund flow, an escalation flow, and so on. And only at the very end, when there's a real demonstrated need, you add a human in the loop for the hard cases and multi-agent orchestrations for context isolation or specialized handoffs. Just look at that order. Every layer gets added because there's an actual need for it, not because it's cool or it's because somebody online said that you need a multi-agent system for anything. That's the whole point. When you add complexity incrementally, your system stays observable. You can see what each layer is doing, so when something breaks, and I promise it will, you can locate the failure because you didn't just bolt on 6 things at once. The opposite is what I watch people do constantly. They wire up 5 agents, a vector database, a long-term memory before they have even confirmed the basic thing works end-to-end or not. And then 2 weeks later, they're debugging a system which is so tangled that they can't tell which layer is failing. And then they rip it out and start over again. I have seen this kill several projects. So, simple thing is iterate intentionally. Add one layer, find the bottleneck, fix it, then add the next layer. And for every layer, ask yourself 2 questions. How does this break? And what does the system do when it does? Remember that half of these failure modes aren't the model being creative and weird. Half of them are boring traditional software problems. Things like a timeout, a null value, an API that went down. If you only stare at the non-determinism, you're never going to see what's coming next. So far, we have talked about the loop your agent runs when it's live. Now let's zoom out because that's where the second set of loops come in. And this one is about how you build the thing in the first place. I really love how Andrew Yang describes building software as 3 nested loops running at different speeds. The first one is Agentic coding loop. It runs in seconds to minutes and it runs by the agent. You give a coding agent a specification, it writes the code, it tests its own work, and it iterates until it meets the specification. So when you're building that support agent, this is the coding assistant grinding on the implementation of it. Now the second one is the developer feedback loop. It would run in about tens of minutes to hours and it runs by you. So you review what got built, you steer it, and you update the spec. You look at the agent and decide any refund over $100 should always escalate, and you feed that correction back. Now the third one is external feedback loop. It runs in hours to weeks and it's run by the world. So real customers, alpha testers, A/B tests, and live production data. That's what tells you whether the agent actually works for real people. And it flows back into your vision, into your spec, and drives the coding loop. Here is a key insight, and notice it's the same asymmetry from earlier. The further out the loop goes, the more verification depends on human judgment instead of automated tasks. The agent can verify its own code, but only real customers can verify whether the product is genuinely good or not. The humans do not disappear. They move to where they have the context and judgment advantage. And this ties the whole video together. Remember the original 4 agentic design patterns, which is reflection, tool use, planning, and multi-agent collaboration? Watch them show up in the support agent live in production. Reflection is the agent checking on its own draft against the refund policy. That's the verifier in the loop. Tool use is the order lookup. Planning is sequencing of the steps, which is classifying, lookup, decide, and respond. And multi-agent collaboration is the sub-agent handling a second task and handing it back with a clean result. These 4 patterns aren't abstract theory on a slide. They are literal building blocks of the loop that you're engineering. So here is what you can actually do now. Spot the point and solution thinking and zoom out to the whole loop. Design your stopping condition and budget your iterations, your cost, and your context deliberately. Take the harness and system level evaluations as seriously as the model evaluations. Put cheap verifiers inside the loop and put humans where verification is expensive. Use Mint framework to build up from minimal end-to-end system and adding complexity only when there's a real observable need. And you can actually see how these three loops actually work with each other. Now, I know it was a lot to cover, so don't worry, all the things that I've mentioned here, I'll be adding some more reading resources for you in the description below, so definitely go check it out. Now, if this really fired you up to building agentic systems right away, that's exactly what we teach at the Gen Academy. It's an educational startup that my co-founder Arvind and I have built together. We deliver a 6-week Mastering Agentic AI certification, and this is not a recorded classroom that you're going to sit and watch alone. It is live with 2 lectures every week, plus office hours, plus guest lectures from some of the top AI experts from companies like NVIDIA, OpenAI, Fireworks AI, MemZero, Replit, Pinecone, 11 Labs, Llama Index, LangChain, and so many more. These are the people who are actually building AI systems in practice. And for projects, there are 2 tracks. One is code heavy for people who are coming from developer or engineering background, and the other one is low code, no code for people who are coming from product management, GTM, or non-technical folks. But at the end of the day, every single week you're going to be shipping a project. Most importantly, this certification is covered by most of the employer's learning and development budget, so definitely check with your manager to get it reimbursed. And for my YouTube audience, I've added a special discount and you can find that link in the description below. I really hope this was helpful, and if it was, please do subscribe to my channel. I constantly post about AI and ML career tips, resources, and technical breakdowns like this one. And if you have any questions, please do drop that in the comments below and I'll take a look. Alright then, I'll see you in the next one.